In this lecture, we introduce some important aspects of a table of standard reduction potentials like the one shown here. In the next lecture, we use the table to write the chemical equations for electron transfer reactions. The table of standard reduction potentials that we use in this text shows all half reactions with the oxidant, which contains the acceptor orbitals, on the left, and the reductant, which contains the redox electrons, on the right. The half reactions are listed such that their standard reduction potentials increase going down the table, so the redox orbital energies increase going up the table. Spontaneous electron transfer is from higher energy orbitals into lower energy orbitals, so an electron transfer is spontaneous if the reductant lies above the oxidant in the table. In other words, spontaneous electron transfer is from an upper right reductant to a lower left oxidant. Consequently, the reductants at the top of the table are strong reducing agents, while the oxidants at the bottom of the table are strong oxidizing agents. Metals are reductants, so all metallic substances can be found on the right side of the table, while their ions are on the left. Copper, copper wire, and copper shot are some ways in which the metal or reductant might be given, while copper sulfate is a common form of copper 2 ions. Note that the sulfate ion is a common counter-ion in redox reaction because most metal sulfates are soluble and sulfate does not react with most redox species. The She at 0 volts is an important half reaction because the redox properties of strong acids are due to the oxidizing power of the proton. Thus, all metals above the She react with acid to produce hydrogen gas, while copper and silver are unreactive to most strong acids. Instead, copper 2+ and silver 1+ ions can be reduced to the metal with hydrogen gas. Nitric acid is one important exception because the nitrate ion in nitric acid is a much stronger oxidant than the proton. Using the half reaction at plus 0.96 volts for nitric acid, we see that both copper and silver react with nitric acid. Water is involved in many half reactions, but it is the redox species in only 2, as a reductant at plus 0.88 volts and as an oxidant at minus 0.41 volts. In the others, such as the nitric acid half reaction, it is necessary to balance oxygen atoms, but it is neither oxidized nor reduced. Note that the metals above the reduction of water all react with water, while those below it do not. Thus, iron rusts, but nickel, copper, and silver do not. The fact that copper and silver do not react with water or acid is why copper pipes are used to carry water and why silver can be used in jewelry.